Hey, what's up, folks? Welcome back to another 3D Hangout. My name is Noah Rezz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro, Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is the show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Thank you so much for joining us. We are live streaming, and we're hanging out in the Discord chat room. So if anyone would like to ask some questions or just say hello, we are hanging out in the Discord chat room, and of course all of the other chat rooms as we live stream across the intertubes.
Giving shout outs to everybody hanging out in all of the chat rooms, not just the Discord. We're on the YouTube, we're on Twitch, on Facebook, and LinkedIn, and Periscope. Good morning to everybody hanging out. Happy Inauguration Day.
Yeah, we'll try to get everybody out before noon, so we'll try to run through some things, and hopefully we have a little bit extra time for folks to get ready. So we'll start off with the things. Again, we are hanging out in the Discord server, so if you'd like to join us, you can join the many thousands of folks that do so. Discord.gg/Adafruit is the invite link.
So we post all the links to all of the different projects and whatever we're talking about, all the materials and the assets, as well as some great commentary always by Mr. Certainly Bruce. Hey, definitely stop by just for that.
All right, and next we will run through the kind of list of things that happen throughout the week. It starts off with Mondays at 2 p.m. Eastern Time. We have the CircuitPython meetings. However, this week and other weeks where the Monday falls as a holiday, we tend to push that. So this week's CircuitPython meeting happened on Tuesday at 2 p.m. Eastern Time. And it gets posted as an archive on YouTube, but you can, of course, join live normally on a Monday at 2 p.m. On the Discord server. And there's a CircuitPython cake. It happened. It's real.
Definitely want to tune in this upcoming week for pretty interesting discussion on some stuff that's happening.
Yeah, some CircuitPython stuff.
Can't say any more about that one, but very exciting stuff.
Adafruit Daily, if you'd like some daily content, you can subscribe to all the various categories that our folks on the CS team write up. So we have blog posts, projects from the community, and more, tips and tricks and all that sort of stuff. So adafruitdaily.com, standalone server website, so we don't spam anybody. So you can go there to subscribe if you want some content on the daily basis. And then we also have a newsletter that happens once a week. This one's focused on the products. The new newsletter. You can go to adafruit.com/newsletter. How was that? That was good. Let's record that one.
Justin in here posting, we might have some maintenance on Adafruit I/O from 11 Eastern Standard Time to about 1 p.m. today. So anybody trying to access their I/O stuff, probably join back right after 1 p.m.
Yeah,
just some maintenance.
My sign. It's like, there it is. All right, it's still running. Because it is an IoT sign. Help wanted. If folks would like to post up their skills, or if you're an employer and you're looking to get some help, you can go to Adafruit's jobs board. That's jobs.adafruit.com.
These are some really good jobs that are vetted by PT and Lamar themselves, and they were mentioning last week that there's some really good
some new openings, some new opportunities. So please check it out if you are so inclined. All right.
Let's see, going through the list here.
Yeah. Bless of Lady Ada happens every Sunday at like hacker times, normally around 9 to 10 p.m. So check it out.
A little bit earlier last week. So make sure you have that bell notification clicked on so you get notified.
I need to rearrange these now because Tuesday happens after Sunday. I will make a note of that. JP's product pick of the week happens every Tuesday at 4 p.m. That's 1 p.m. PT time. Perfect time.
Yeah, that's where he goes over all the new products that are released along with some cool demos, code to go along with that, and as some people were saying, it was a little bit more than 50% off on the current product for that week. It is streamed right on the product page, but you also get to it on Twitch and Discord and YouTube and all of the other streaming services, but definitely check that out every single week, Tuesdays, 4 p.m., 1 p.m. PT.
All right, I'm still stalling here. On Wednesdays, we do the show at 11 a.m. That's what you're watching. But later tonight, we'll have show and tell, so we invite you folks to come on. It's not the end of the show. I'm just running through all the show stuff. And those two shows tonight. yeah, show and tell. We invite you to come on 7:30 p.m. and then shortly after that is Ask an Engineer at 8 p.m. Lots of new news and things going on. Now, we're almost through because Thursday we have John Park's workshop. Happens every Thursday at 4 p.m. Eastern Time.
3 cool projects involving MakeCode, MakeCode Arcade, and more demos for all the cool products and boards.
Yeah. And then Scott happens on Fridays, sometimes on Thursday, but this week is Friday.
Interesting one this Friday.
I think
I'll tell you that.
We'll see. There's some
very interesting one.
There's some things yet to be announced that
there's
we will.
Actual secrets that we don't.
Oh, there's
talk about
secrets.
What? Tune into that.
Where's my secret? Like, I don't have a secret banner. Like,
it's an actual real secret one.
Yeah, I don't have a secret banner. We should come up with a new banner. All right. Well, with that out of the way, we're gonna jump into this week's project. And it's a fun one. It's been a long time in the making. So this week is the release of the Darksaber. This is a 3D printed prop from the Star Wars Mandalorian season 1 and 2 and 3 and how many ever other seasons there will be.
It's confirmed he'll be back for season 3.
Excellent. Well, this is the Learn Guide. It's public. Folks can check it out.
Oh my God, it's a huge Learn Guide.
It's a massive guide because the assembly is documented to the teeth.
Yes.
If that's, I don't know if that's the slogan, sorry. Yeah. It's got a lot of photos, over hundreds of them. So we're going to walk through some of the build stuff. And if you have any questions, well, now is the time to
right
ask
off the bat.
them.
Woohoo 007
Right.
and Catlip is asking about the NeoPixels. No, you do not need to get that. The $100 price tag is for a 4-meter, I believe, right? The whole reel.
Yeah. Yeah, that's the way it's. We'll talk about that, but yeah.
They're as cheap as, what, 15 bucks?
Yeah, it says like $100 for the strip.
This
yeah,
is
that's
for
a whole
a
reel of
reel.
it. That would be 4 meters.
Yeah.
You only need 2 meters. And we're out of
sorry
stock
about the
on
sticker
one.
shock there.
Yeah. Yeah, it's 50 bucks. But whatever, LEDs you can find that'll fit, you can use them. Excellent. All right.
So just wanted to get that one out of the way.
Yeah, sure. That's fine.
It's still considerably cheaper than going to Galaxy's Edge or...
Yeah.
What was the pre-order price for the Hasbro one?
There is a Hasbro one. I forgot
sold
the
out.
price. Yeah, I think it's like $250 or so, and it comes out in August.
Mm-hmm.
Ships in August. All right, so yeah, the homepage just walks you through a couple of the features and things. It's a little bit different. It's a lightsaber, right, that has Bluetooth control, so you can use the Bluefruit app. It's free to download for iOS or Android, and you can use the color picker to change the color of the blade. So that's really cool. We'll do a demo of that shortly. I got a list of prerequisite guides. It's something that we tend to do with all the guides, just so folks know that there are independent guides for all the products. So for the Feather NRF52840, if you want to know all the pinouts and all the features for that Feather, you can check out the Learn Guide for it. There's a Learn Guide for just the PropMaker FeatherWing. So if you're making a project that's completely custom, you're going to want to take a look at that so you can see all the pinouts and all the details of, like, how many watts does the amplifier pump out, that sort of thing. And then, of course, the Welcome to CircuitPython. If you're super new to CircuitPython and you'd like to learn more about it, we have 2 guides. The Essentials Guide will walk you through more of kind of the nitty-gritty stuff and example code. But if you just want to build the lightsaber, you can kind of skip all that. but I take a moment to read it. So yeah, all the products are here. Again, about the mini skinny, you do need 2 meters worth of it. There are 35 LEDs on 1 strip, but there are 2 strips inside. So 35 times 2, that's the number. 120, right? 70, sorry, not even 100 pixels. Only 70 pixels are in here. So yeah, you could, of course, use a higher density strip, but I think you could get away with even a low density strip, since the placement of the strip is inside the blade in the center of it. You're going to get some decent light diffusion, whichever density of strip you use. Good. Battery, this is running the 2200 milliamp LiPo battery. It's good for a few hours, depending on your brightness settings. This uses the 16 millimeter RGB LED button. This is the latching type because it lets you do on and off via the enable pin on the Feather. And then the mini oval speaker. This is a nice little strong speaker that we like using in all of our embedded projects. The rest of the stuff are cables. Lots of different cables. JST cable for the NeoPixel strips. silicone ribbon cables, as we tend to like our wires to be nice and neat, and using ribbon cables tend to really help do that. And a bunch of Pico cables, short headers, shrink tubing, tools, all the different tools that Adafruit stocks is good to help you build this thing. A stick vise, a pan vise, helping hands, and some of the ancillary stuff like poster board. This is what's going to create the insulation for our 2 NeoPixel strips. It's double-sided back-to-back mini skinny strips. I love saying that. Double-sided tape, of course, for the covers. All right, so then that leads me to, well, why don't you guys come up with a kit? Well, we have a kit. It's called the PropMaker Lightsaber Kit. I guess the Adafruit PropMaker Starter Kit. It changed. Awesome. This is great. So a couple of things about this. I went ahead and kind of broken out what are the things that will, out of the kit, that will work with the Darksaber, and what are the things that won't work, right? So the PropMaker Starter Kit comes with the M4. The Darksaber build uses the NR52840 feather because it has Bluetooth control, so the code is written for Bluetooth. We can kind of rework it. We could use the lightsaber code from the lightsaber project, of course, so you could use that if you don't want BLE control. So there's that option. You can do whatever, but there's that option too. Another kind of main part of the kit is this speaker. This speaker that's a part of the kit is a 40 millimeter. The size of it is the diameter is 44 millimeters. Doesn't quite fit in the handle, so weren't able to use that one. But the battery fits, so that's cool. So you get the battery. Of course, you could use the PropMaker, of course, and all the cables and heat shrink tubing. All that stuff will work fine. The button, however, the button that's in the kit is a momentary button. The one we're using in the Darksaber is a latching button. So you could, I guess, rework the code a little bit. But yeah, that's the way it's set up. So if you want to get the kit and you want to build the lightsaber, that's for you because that's pretty much what the kit's for. If you want to build a Darksaber or not sure what kind of prop you want to build yet, well, that's why the starter kit is there. So I figured I'd kind of run down some of the lists, some of the features here on what, like, if you would want to use the kit on the Darksaber. There. Any questions on that? Because I'm still kind of like, okay.
These comments so far.
We're good.
We have Yanni's comment on, yes, the Infinite Z belt printers.
Oh, I can't wait to talk about that.
Yes,
we'll
talk about that in the 3D
version.
printing section of that.
All right, let's write into the circuit diagram. Here's what the circuit looks like when the stuff's pulled out of the hilt, right? Cool. There's quite a bit of wires here for the RGB LED button because there's, well, RGB LEDs in there. So I made a custom part in Fritzing. Fritzing is the open source software that we use to create these wire diagrams. There's a library for Adafruit parts. So if you'd like to create your own with all these parts, you can use this link here in the guide to kind of create your own circuit diagram if you'd like for other projects. But however, I was saying this little button here is kind of custom built. So I built that, and there's lots of labels and stuff there. And the labels are also on the button itself. There's so many pins on it, so that's why it's really helpful to kind of make a little table of connecting the RGB button. So I hope that's very helpful because it's all broken out here. So yeah, that's good, right? For folks that are new to the Feather kind of platform, it has built-in LiPo charging. So when you connect it over USB and you have a battery connected, it'll just go ahead and start recharging the battery. So that's really nice. One of the best features of a Feather. So that's about it for the fritzing part. A lot of the things just plug in, like the battery, the NeoPixel Strip, and the speaker. It just plugs right into those ports on the PropMaker wing. So that makes it a little bit easier. However, some of the wires that come stock with the speaker aren't long enough, so we do have to extend them. So I cover that in the guide as well. All right, that's the circuit diagram. Let's head on over to the 3D printing page. There's some pieces, none of them require support material. I'm very happy about that. So I spent some time over the weekend to make sure that the parts can fit on even the smallest of 3D printers. Well, what would that be? A build volume of 140 by 140 by 150 millimeters. Flip that, 150 by 150 by 140. is the kind of minimum bed volume that you need. I think most 3D printers these days are going to be around that. Do you know what the Prusa Mini is? Is that 150?
I want to say it's about that size.
Okay,
so
well, for us, what we have on hand is the Inventor 2 from FlashForge, or maybe it's Monoprice. I made sure that all of the blade parts, the hilt, all of that fits on the bed. A little bit of a tip, though, you do have to rotate the blade parts at 45 degrees so that it can actually fit diagonally across your bed, and that increases the bed volume a little bit, enough to like print this piece. So I hope folks can, with smaller printers, do in fact do it, make it cool. Just a couple of slice settings. Folks can use, of course, other material other than PLA. For example, PETG is a great option. So these slice settings will vary. So this one's just for what I used on my Flash Print and Cura slicer, because those are the slicers for the Inventor. It's the Flash Print, that's what they call it. So yes, all right, cool. The next kind of sections talk a little bit about the assembly. The assembly will change depending on what pieces you have. In terms of like the smaller bits, you're gonna have to glue those together. The other bigger like the single piece hilt just prints in one piece, so you don't have to assemble that. But these just show you how the hilt and the blade emitter and the crossguard all fit thanks to the coupler that's embedded inside. So that's what that GIF is showing. Then the blade assembly is more is very specific to the 2-part blade. If you have a 4-part blade, I have omitted all of the screws because you're going to glue them anyway. So that's 4 pieces for the blade, and those are all glued together. But if you have the 2-part assembly, you want to use these screws and hex nuts. They're M3 sized, and they're about 10 millimeters long. And that's all listed here in the overview page, like the screws you'll need. All right, and then I went ahead and kind of said, all right, well, there's a lot of parts now, so I might as well break them all out and name them and categorize them. So I hope folks will use this to kind of figure out, okay, these are the parts that I want to print from my printer. So it's always complicated when you start splitting stuff up for particular printers. So parts for all printers, these are the parts that will fit on just about all of the printers, big or small. Okay. One note, there is a little piece here that is, I recommend using TPU filament. That's that rubbery soft filament for the button O-ring. But you could try PLA. I think it will be okay. It's just like that extra grip that you get for the button O-ring. The button O-ring is this little extra kind of bit that really secures the button. And it's getting a little detailed here, but I might as well say that this is kind of the only NinjaFlex piece, and it's just a tiny little ring. You know, I bet you could probably fashion your own with rubber band or something, but I might as well make that little piece and say it's for TPU filament. Parts for the small printer. So the blade covers, the blade pieces themselves, 1 through 4, and then the hilt top and the hilt bottom, because the hilt got separated into 2 pieces. I even said, like, here's the kind of build volume that that this is recommended for, like minimum. And then here's the parts for the big printers. This is the size 300 by 300 by 400 millimeters. That's about your average CR10 build volume. So what'll fit on there? The hilt is 1 piece. The blade is in 2 pieces, and the blade covers are also in 2 pieces. And then we get to the parts for giant printers, because I specifically wrote for belt printers, but then on Twitter,
Gmax?
Dave Darko was like, hey, I bet Ivan's printer could print it, and he's got this massive like printer. It's like, okay, I guess you don't need a belt printer for everything that's massive. You could just have a massive room printer. So that's a small part compared to that. But I figure I'd say like, hey, this is the full size, or rather the full length of the blade, 670 millimeters or 26.4 inches long. And it's a single piece. I am not able to print my blade in a single piece, so it'd be really fun to see someone do that. Same thing with the covers. So you only have 1 blade piece and 1 cover. You do have to print it twice, the cover, because you just mirror it. All right, so that's the giant printer pieces. And then there's parts for the stand. So I have a stand, and there's some extra pieces here for different setups, and I'll show them later in the show. Okay, so that is the 3D stuff. two links here. You get the STLs if you just want the STLs as is, or if you want to modify the CAD, I have the step file and the Fusion 360 file if folks really want to go in there. There's user parameters and all sorts of fun ways to modify the dimensions. So check that out. Cool. Any questions?
Yeah, we have Wahoo or Hoo-Ha 007. Adam was asking about the lower density black mini skinny NeoPixels. And yeah, that'll totally work. The only difference is you might see the individual pixels shining through. Maybe
not.
May or
maybe
may not.
So.
You can kind of see these. This is medium density.
Yes.
And you can kind of see where each individual pixel is on that. Not on camera. Probably not on camera.
Probably more up here you could see that.
So that would just be more...
but it's pretty even. You know,
oh, there
I think it'll be pretty
even. You can see when it dims
down. Near the
down.
top because of it's starting
when
to
it dims
skinner.
down, you can see each individual pixel. So that'll be the only downside to using the lower density.
Right, but you do get more battery life because you're powering less pixels.
You get more memory too for more animations.
That's cool, yeah.
And if you didn't do any post-processing on this, so you could go in there and add more diffusers on the inside, or maybe add like a piece of paper or something in front.
100% infill, you could do whatever.
Yeah,
you know?
you could do that, and that would definitely help with being able to not see each individual pixel. So you could definitely go that way. It would just be a little bit more work, or if you don't really care about that look,
yeah,
it'll work perfectly for that.
For sure, yeah. Yeah, I foresee folks using their own pixels, and I'm sure folks have some strips that they got on Amazon that you could probably use as well. Yep. You got it? You got it. Cool. All right. Good question. So that is the CAD stuff. All right, the next pages, I figure folks would start, get a feel for the circuit diagram, feel for the parts, and now it's time to get the code onto the Feather NR52A40. So we start off with installing CircuitPython, the latest version of CircuitPython on your Feather. So this page walks you through that pretty quick. You can do it fairly quick, yes. So let's move on over next to the code. I want to give a big shout out to Liz Clark. She helped us put the code together for this. It's a mashup of the Master Sword code, some BLE color picker code, came together and it works really well. So here's a list of all the libraries that you're going to need. Nice handful of libraries. Here's a screenshot of what your drive looks like. So your CircuitPython drive. Whenever you install CircuitPython on any of the Adafruit boards, when you plug it into a computer, it shows up as a USB drive. Your code is there, your libraries, and your sound files, because this is, of course, a prop with sound. So next up, here's a list of all the sounds, the WAV files, and a little bit of note. The CircuitPython supports the WAV format. It's a 16-bit. If you want to create your own sounds, you want to use this information to convert your audio clips. Cool. And then some of the naming conventions here. So you can change them out if you want to change the names, but just 3 kind of groups of sounds. You have the, well, 4. You have the on sound, which gives you that kind of power up sound, the idle sound, which is just the hum, and then you have up to 4 different hits. Those are those crashes, and 4 different swings. You can add more or less as you'd like, as much as the space allows on the 2 megabyte SPI flash that's on there. Or maybe it's not SPI flash. I think it's the memory is probably built into the battery. Anyway, so here's the code. It is on GitHub. Folks can grab it, fork it, and all that stuff. So it will forever live on GitHub, I think. And again, shout out to Liz, shout out to Lamar and Katney too for kind of doing the kind of Gen 1 version of the lightsaber. And now we're here in the Darksaber. It's Bluetooth. It keeps evolving, so that's awesome. So if folks want to use different animations, you can of course do that. You can change some of the thresholds for the sensitivity on the accelerometer. So if you want to really fine tune it, you can do that. Here is the NeoPixel setup. So if you have more NeoPixels, it's actually 34. I said 35. Whoops. Let me redact that one. And of course you can change the pins, but you want to leave the pins here because of the PropMaker, right? Okay. Yeah. And then here are some of the animation setups here. You can change this up. So yeah, I think that's about all, folks. Oh, if you want to add more swings, you can append some new ones to these arrays here. So if you want to add more hits, just kind of go with 5, 6, or name whatever you want. As long as this name here matches your audio file's name, you can add as many of these. And they play randomly as well. As you keep hitting it, it'll just randomly play the next one. Okay, I think that's about all the kind of customizy bits that folks would want to do. So there you go. All right. All right, so then the next pages really break down the sections of assembly. So setting up your headers on your feather. You want to use the socket style short, what is it? It's just they're called short headers on the Bluefruit because we want to have the PropMaker on top. I like to use the breadboard when installing my headers.
Line up all the pins.
Yeah, it lines up all the pins and keeps it in place. And then the trick here for installing female headers is you actually put those socket headers into the header pins, and then you can place your board on top, and then you can secure that down with a vise and solder it in place. Wiring up the PropMaker. We got these series of cables, and we want to increase the lengths of them, or rather decrease the lengths and make them shorter. So I have all the cable lengths here for all of the cables and the wires. So I just walk through that here. Setting up all my wires is what you want to do first. After you've soldered all the headers, it's wire time. The first sets of wires that I recommend is the PropMaker cables. So that's going to be the RGB button and the switch, or rather the enable and ground pin, because that's what's going to turn off and on the circuit. So I walk through that. All right, wiring up the button. There's a lot of wires here, so that's why everything's broken out. We're slicing, or we're kind of adding. We're making it longer. We need to make the wires longer, so that's what we're doing. The other one we made it shorter. Now we're making it longer. So this just walks through all that. Here's a nice little image of the pinouts for the button. I kind of ripped this from their data sheet and just made it more clear, so folks can use this and look at the labelings to help, because I did wire this wrong quite a few times, so I figured this will be very helpful. Cool. And it's hard to get a good photo of it because like all the pins are in different spots, so I hope that helps. So there you go, wiring up the button. Once it's all wired up though, it's easy to disconnect and connect it to the cables that we started to the PropMaker. And at this stage, you can actually test the button and test the circuit turning on and off because it's already wired. So that's cool. That's kind of the first circuit test there. Wiring up the speakers, fairly straightforward. We just need to increase the length of it. So we do that. NeoPixel Strip assembly. Yes. So here's the full reel. That's what it looks like. So measure and cut it. What I did is I just kind of unraveled the NeoPixel strip and tried and measured it out with the actual blade. So we haven't put the blade together yet in this kind of chronological order, so just bring the 2 blade or 4 blades together if you haven't glued them yet, and just to get an idea of what's the length you want to get that will fit in the center channel of the thing. So once you figure out the length of strip you want, or that you'll need rather, then you can start to create the insulation, because the way this works is we have 2 strips that are back to back, but we can't just put them back to back because on the bottom of the NeoPixel strip are pads. And if those pads touch other pads, they're going to short each other out. So to prevent that from happening, where you can use a couple of number of different things, I'm using poster board, which is a piece of plastic really. It's a kind of a thick, maybe like, I don't know what's the thickness, maybe 1/2 millimeter thick. And that's enough to, stop the things from, it's non-conductive material. So whatever you can find. Originally I used Kapton tape, but I was like, well, that's a lot of tape to tape up all of the things. So I went with this. It's just a really big piece of poster board. That's what it's called here, poster board, but you could use paper, I think, or something else. So if you'd like to fashion your own stuff,
paper would work,
I think. Yeah. Just make sure it's not too thick. So you'll want to measure out the thickness of this to make sure that it still fits in the channel, in the blade. All right. So then to join this, like to bring those 2 strips And then sandwiched in between that insulation material, I'm using double-sided tape. Also just regular Scotch tape to kind of wrap it around. Yeah, so because of the LEDs have enough spacing, I was able to use that spacing where the LEDs aren't so that the tape wouldn't block the LEDs. I guess you could do that. You could tape up the LEDs, cover them up because it's transparent tape. It might actually diffuse it. I didn't even think of that. So here's a photo of like the thing together. It's kind of hard to see. You can, of course, click on the image if you want to get it to look bigger. I clicked on it and held down the command key so I can open it in a new tab. But here's the original image. It's about 5K or so. But you can see here that it's in the middle. There's some tape right here. Yes, there's some tape right there. And there's some tape right here. So like every 4 or 5 LEDs, I'll wrap some tape around it. That way it really maintains, what do you call it? It maintains its kind of...
its shape.
Its shape, yeah. So here's what it looks like. It's kind of cool to see a double-sided strip. You don't want to bend it too much though, because you could, I don't know, break the tape or something. So yeah, then put it up next to your blade and you're gonna get ready to install it. But first you gotta wire it up. So I walked through the wiring. These probably are the longest wires. And what I ended up doing was using 2 sets of cables with 3 wires in each set. So you basically have 6 connections, but we're going to splice them and merge them together into one cable. So I walked through soldering up those 2 strips individually with 2 of those cables, the ribbon cables. We're going to use some heat shrink tubing to insulate them here at the corners there, so that's nice. And then let's get a bigger image of this just to show what's going on here, kind of the technique. So here you can see, let's do an original, all right? You can see that we have 1 of those cables from the JST connector, and then we have 2 of these ribbon cables. So both of these, right, are from those strips, and they're both the voltage wire. So I use 2 sets of third helping hands to keep them in place while I can just put some solder there. And that was, I think, the easiest technique for me, to bring 2 wires and soldering it to 1 wire. So that's what we're doing here. And we pretty much repeat that process for all 3 of them, for all 3 wires, right? For the power, ground, and the data. You want to make sure you're using data in. I forgot to say that in the beginning, but if you're walking through it, it says that. And here's what it ends up looking like. 2 cables form into 3 of these wires here with heat shrink tubing there to insulate them. Yeah, so I think that's good. And then here's what the kind of the total length of the cable looks like. Looks like that. It's nice and long, and it should fit through the whole hilt. So at this point, we can start plugging things in and test out the circuit as is. So this is what it looks like at this stage. You can plug everything in and see if everything runs. You can test out the LEDs, the button, the speaker. Everything should be working at this point. Cool. And now it's time to assemble the thing. So I walked through assembling the blade. This is going to change depending on which blade you have, whether it's the 2-piece or the 4-piece, or maybe it's the 1-piece. Either way, once that's assembled, we got to install a kind of a cap nut into the tang. That's this piece here of the blade, and that right there allows us to secure the blade to the emitter once it's fitted inside. All right, so at this point, I install the strip into the blade, and then we get the wiring to fit through the tang. So the tang has a little bit of, where did it go? Let me try that again. Here we go. The tang has some extra opening here for the cable, for those 2 cables to pass through. So that's why there's more room there. Nice and roomy. All right, then at this point, look at that GIF. You can test out the light diffusion at this point, once it's inside the blade. And now we gotta install it. So definitely walk through this assembly as you need to install the emitter in the correct way. So I have these photos here. We're getting the blade emitter into the blade. That slides in there like that. Make sure none of the wires get kinked. then we can install that screw. Remember we installed that hex nut? Well, here's why, because now this screw is gonna catch onto that hex nut and get a nice solid connection. And then that's what it looks like there with the blade emitter hooked up to the blade. All right, and then we're getting the blade covers next. I found a little tip here. So if you print out your two covers, joining them together seems to allow light to leak through where those two covers meet. So what I ended up doing is use a piece of vinyl, or you could use electrical tape, to kind of mask these two. So like bring them together and then put that tape on top, and that'll prevent any light from leaking through that seam, that joint. So that's what I did here. Yeah, I just laid it on top and then trimmed it down here. You can see here in the image here, I just like trimmed it down, and now these two are kind of taped together with black tape. So once that's assembled, then you can start putting some tape across. Whether you'd like to glue it is up to you. I chose not to glue it because I like it to be modular. This is Nitto tape. You could use double-sided Scotch tape, but I used the Nitto tape because it's a little bit stronger. But yeah, you can put as many as you want here. I tried to spread them out a little bit so that if I ever need to take it apart, I won't have to fuss too much.
And while we're on this section of the assembly, we have Armin VP, who's asking about the black covers for the print. He's saying that the Ender 3 leaves a rough finish on the top side of the flat print.
Yes. Perhaps there's some tools, I think, in the Prusa slicer that allows you to kind of iron it down, comb it down. You could, of course, sand it as well. Or if you have access to a vinyl cutter, you can actually cut the whole cover. I offer SVGs of that. So if that was one of my plans. I just forgot to order long vinyl. But yeah, on a vinyl cutter, you can like go as long as you want, which works great for this project because you can cut that whole cover out of vinyl. Problem is, or rather not a problem, but the next thing to do then is to transfer that vinyl onto the blade. Now, how do you do that? Well, I don't know. You need maybe another set of hands. I just foresee that being difficult because whenever I apply vinyl,
this is quite stick to the
it's just hard surface to apply it and to guide it and have it perfectly applied on the edges and to avoid air bubbles and all that. Maybe that's why I didn't do it. But I wanted to.
So Who Had 007 Adam is saying that you can just get a cheap smooth surface plate for the Ender 3. Yeah, so like a PEI sheet, the spring-loaded, the magnetic sheets. We used glass, but you can definitely use the PEI sheet, and that'll give it a nice smooth finish. Make sure that your leveling is, not digging into the bed. That'll avoid the rough finishes for that, or the top as well. Yeah, and to try out the ironing, that might work. Yeah, the ironing feature. And is it Prusa or does? It's Cura. Cura does it too. Prusa. Yeah, I think they all do it. Sweet. Well, I mean, once we get them in, once we tape our things together, that's what it looks like. Yep. We could knock down. We could have sanded this down and painted over it, and there's a lot of post-processing. Basically, no post-processing was done on our build. None, because we ran out of time. But hey, folks are definitely going to do that. All right. Next up, we're setting up the coupler. A little tricky to get these hex nuts inside of the coupler, so I recommend using tweezers. So here you can see I'm fitting these tweezers in there, so I could so I'm using a long M3 screw, fit that in through one of the screw holes, bring in your tweezers with your hex nut in there, and then just start to kind of build the ship in a bottle. But hey, once that's set up, you can just fasten the screw to do this here, to tighten it. It has a tight fitting, so you're going to want to have to use a little bit of force to press fit that in when you're screwing in the screw there. And I'm using lock nuts here with a nylon insert. All right, so once those two hex nuts are in there, then we can fit the I want to call it a cross guard, but I think it's just a guard. So we can fit the guard over the coupler, and then we start feeding in the NeoPixel
cable through the coupler with the guard installed. And then here's a little kind of, make sure it looks like that. So once that's fed through, we can start securing the coupler to the blade emitter because we fitted it on there. And now we have our pretty much assembled blade emitter guard coupler. And at this point you can plug that into the NeoPixel port on the PropMaker and test it out. Because we did all the work of setting up our covers, we want to see how it looks. And it looks pretty good there. All right, next up, button assembly. Here's that little washer, the little Ninja Flex TPU washer there. You can fashion your own, but that's what I use, Ninja Flex. So this one gets fitted into the hilt. There's a hole for the button in the hilt. Pass those cables for the button through that hole, and then get those hex nuts and washer in through those cables, and then feed them back in through the handle, and then kind of push them all the way out. This shows it was hard to get this shot because it's kind of a tight fit inside there. There's enough room for the cables to pass through, of course, but you can see here how, because of the shape, the oval shape of this, I couldn't quite secure the stock hex nut onto, because the body of the button is threaded. So what this allows you to do is it just gives you that extra bit of space that you'll need to secure that hex ring. So that's what that's doing. And that's pretty much installing the button. And then just pass those cables through. So here is the on-off cable and the cable for the RGB button, like the LEDs rather. All right, and then we're walking through the feather. So installing the feather into the PCB holder. Use a combination of hex nuts and M25 screws because those are the mounting hole sizes for the feather. So I run through that. Before you can secure the feather to the PCB holder, you kind of have to connect some stuff. So that's why I walk through connecting the bits that you need to connect first. But I preface it with, hey, you should install these, the screws and hex nuts into the board and then connect the speaker, the battery, and then the RGB button here. So that's basically what we're doing here. And then we can, well, almost then. Because, well, we got to now install the cable. So we fit the cable, the NeoPixel Strip cable through the hilt, pass that through the bottom, and now we can start to assemble the hilt into the last remaining piece of the coupler. So we do that. And then now it's safe to connect the NeoPixel cable to the NeoPixel port on the PropMaker. Let's go ahead and fit the speaker into the speaker holder. Without this holder, your speaker will just rattle around in there. So this specially designed holder press fits. You just press fit the speaker in, and there's a hole on the other side so you can still pop it out. But no need to glue it in place because it has a tight fit. Battery just slides into, it doesn't clip, it slides into it. So don't clip it, slide it in. That's the method there. And because of the shape, we'll walk through in a little bit here. Now, after the battery has been fitted into the holder, then it's safe to install and secure the feather with the PropMaker wing on top into the PCB holder with these extra hex nuts here. And that's what it looks like. You do have to trim the screws, but they're nylon screws, so it's super easy to trim. And then you get these nice flush little screws. All right, and then here's just a shot of like looking at it inside the thing. There's still plenty of room for extra connectors and cables, so that's nice. And that's the PCB holder. All right, so the first thing that gets, well, rather the second thing, I guess, that gets installed into the hilt is the speaker. So the speaker is fitted in, passed through. It should slide in there nicely. Followed by that is the battery holder. Before fitting the battery all the way through, I start to fit the cables from all the, I'm just cleaning up my tabs now. I have to fit all of the cabling through those little sides of the battery holder. So you can see here that in these little areas here, you can wedge in those connectors, and that helps to kind of organize, keep the cables from being kinked and organized, so they pass through there nicely. So once that's in, you can start fitting it in through the hilts, and then just push it all the way through. And then from there, you can start to feed in the feather holder, the PCB holder rather. And then that's about it. So there's a little bit of an extra geometry here at the end of the PCB holder because that allows you to still pull it out. So if you ever need to pull it out, you can just grasp onto that ledge and pull it out. And that ledge prevents the PCB holder itself from being shoved in all the way. Because of that ledge is there, it prevents, maybe it's a flange, it prevents it from being pressed all the way into the hilt. And then the pommel can just fit on top of that. There's no screw or anything for the pommel, it's just a press fit, and it just pops open if you ever need to open it again, which you will when you want to recharge the battery. But that's it. That's the hilt assembly. The next page just walks you through kind of playing around with the app. Pretty self-explanatory. You open the app, you download it first for whatever device, open it up, and once you turn it on, it'll start advertising itself. So now that it's on, we can go to our mobile device and type in Bluefruit, and we can change up the color of the blade. Okay, so once it's on, you'll see that that it shows up as a Circuit Pi device with a little bit of a unique ID. This is currently white, so I'll go connect. Establishes connection. Fairly quick. We go to controller. Under the controller module, there is a color picker module. So let's click on that. We can change the color. You ever seen a red Darksaber? Or how about a pink one? Purple?
Well, the rumor is that it's powered by Beskar.
Oh, that's.
I don't know what that means, but
Yeah, it's powered by metal. It's yellow.
So a really quick question that I got on Instagram, I think a couple days ago. Somebody was asking, they had built the lightsaber and was wondering how they could add Bluetooth connectivity to it.
Oh, this
It's
is great.
as simple as just switching out the M4 for
Right,
the
because all the connections
Bluefruit.
and everything will work because it's all the same PropMaker. They're all the same pins. So here's the watch device, the Apple Watch. It's a companion, like it just automatically comes bundled with the Bluefruit app when you get it for iOS. So this lets you do a different style of color picker. It has like palettes. Shout out to Colin Cunningham for coming up with these. So these are, I find these are better than like picking the color wheel. Like you're sure you can fine tune the colors and all that, but these are nice sets of shades.
Super quick to get to.
Yeah, it's quicker to kind of control these. If you're in a tight spot or something, I don't know. But any manner, there you go. Yeah, so you can have your pick. And now that the mobile app runs on like the M1 devices from Apple, I guess you could use your desktop too.
Yeah.
That's neat.
I've posted about that. It looks super cool, just running it right from your computer so you don't have to have another board to take up that spot. And of course we made two of them. One for building in the video.
Oops. Yep.
So obviously for these, it's really good for taking photos, but in terms of battling, they're not, maybe if you print it in PETG and have like, 5 walls or perimeters, that might make it nice and strong, but we're not gonna test that. We have tested it with the lightsabers, which
I did drop it and it did survive, so that's cool.
One of the other things that was tested too was making these out of acrylic too.
Yes, the blade. Yeah.
The blade.
So I have SVGs of the blade, so you can laser cut this with some different material. So if you'd like to go that route with acrylic, you can use those SVGs, and it fits in the emitter. I have tested that. I just didn't actually go through and build the blade out of acrylic.
Yeah, it was pretty expensive for getting the acrylic parts. Definitely a lot more better.
It's about 50 bucks. It's not too bad.
Yeah, but if you already have a printer that can fit all the sizes on there, even if it's just the smaller parts, it's gonna be a lot more quicker than ordering something. Or if you already have a laser cutter, go ahead and try that. You didn't like it just because of the amount of time that you had to spend on actually sanding down.
Yeah, I spent the day sanding, and I was like, oh man, zen. Let's see, some other things I guess I could say.
The stands, definitely want to
Oh,
print out
thank
the
you.
stand.
Oh my goodness. So the stand, we're gonna have to rework the shot here. I think it's okay. Let's just do something like
Here's
this.
the stand of this.
You just go like that.
This is modeled after the Hasbro version.
Yeah, and I'll pull that up too. So yeah, it's a fairly large stand, and it has these snap fit pieces. So these just kind of clip into these little pieces here. So the top gets this top here, which is open, and then this circular bit fits over here like that. But it prints flat like that, and these pieces are printed separately. So it stands up like this, and then Peter's going to put it in. So the pommel, this is fitted for the pommel, and then this guy right here just rests right there like that. And there you go. Is it tippy? Not too bad. I would maybe add some rubber feet down here or something to to keep it from sliding around the table, but that's the way I have it set up. And so far it's working out really, really good. Like it hasn't fallen off of the stand yet, so that's cool. You really want to line that up there. There you go. There aren't any edges there because of the way it's printed, so that prints without any supports, but there you go. A couple of patterns here to make it look like Star Wars, right? But it can fit like this or like this. Right, so one of the things that, that I want to say is that let's say you want to take the pommel off, right? You just take that off, and then you put it down here. It's going to fit all the way through. I guess you could have it like that, but I printed out an extra piece here, and this one has a little lip on there so that it catches it right there before it falls through. So that will catch it there. So if you want to charge your battery and have it on the stand, there's a USB port. So you can have your cable pass through here like that, and then just kind of have it either in there for charging, or if you just want to reprogram it and have it on your table like that.
Yeah, it's perfect.
That's great.
Little stand for testing out any of your animations or programming for that.
Now you could use support material for this, but it doesn't matter. The printer should be able to catch that, so that is printed without any support.
Even if there's overhangs, it shouldn't interfere with anything.
Right, because what you're
Just trim it
touching
off.
is the edge here. So there you go, there's the pommel.
Yanni's saying that needs lights too. I'm thinking he's talking about the
right?
stand.
The stand would be
There
cool.
is lights in there?
I would love it to be wireless charging. That's going to have to be for V3, right? A wireless charging thing would be super cool. So if you put this down, it starts charging. Like it makes it sound.
And then Ken is saying that after watching this, he really wants to try this out. He might have to
Yay.
change his near-term printing making plans.
Okay.
Yay.
Yeah.
This is definitely a really good one to try out. The next ones that are coming up, Lamar requested the Ahsoka.
Ahsoka's smaller
lightsabers,
blades. Yeah.
Smaller blades.
Yeah, I can't wait to make another lightsaber. I've learned so much here when it comes to assembly and disassembly that I really want to apply all the things that I learned to the lightsaber build. Because right now it is definitely, I think, more intensive. Like there's just more steps, there's more wires. This is the original lightsaber build. This is what really is for the lightsaber kit, is to build this very exact same thing.
Let you plug that in just
Yeah,
so
sure.
it's on.
Yeah, and here's one of the things I kind of want to prove on it. The actual PCB is in here, and I have this battery here. You could keep it on because it kind of the button here literally turns off the NeoPixels. So when you turn it on, you can also turn it off. So that's one feature, and it's super loud. The speaker is so much louder. But what's cool is that it does go into a sleep style state. So when I turn this off, it's not actually turning it off. It's just telling the code, hey, play the off mode, and then like go to sleep, as in like turn off the NeoPixel and the amplifier. But the code's still running. It's just in this kind of sleep state. So when you want to turn it back on, there you go. And it is super loud. One of the reasons why it's thicker is because, well, I wanted to accommodate space for that big speaker, so it is bigger. When it comes to ergonomics, like this isn't the best. It kind of hurts my hand. This feels so good, as it's
a katana shape.
It's shaped like a katana, and that really helps with like holding it. And it's like sure, it looks cool. Well, it's just it's more ergonomic. And this extra button here. Currently, it doesn't do anything, but you could program it to do something like change the color.
Yeah, somebody
has,
color.
yeah. But yeah, I'm starting to see other folks reworking it, and I can't wait to rework it. I really want to fit this down here and then bring the speakers somewhere else.
The other cool thing is that you can actually battle with this one since it does have a polycarbonate blade.
And it's pretty strong here. This is all nice and thick. But yeah, there's definitely some things I want to improve. So there you go.
Another question from Whoha007 Adam is asking, is there enough room on the chip? I think he's talking about the Feather to copy over the entire library, make life easier.
Yeah, so not currently. I guess if you had like the SD card add-on, you could fit the whole library bundle, right? Is that what we're talking about? The library bundle? Yeah, the library one's kind of big, and you don't need all that extra library, so that's why in every CircuitPython guide, we have a list of here's the libraries that you need. And I think at some point we're going to make a video where it's like, well, why? You know, how do you install the bundle? And, you know, why? What's the method and why? So there just isn't enough space, and you want to just put only the libraries that you need. For this one, it's the NeoPixel library, the LED animation library, the Bluetooth library, and the LIS3DH, which is the model number for the accelerometer. So those are the libraries. Some of the IoT ones have like 12 libraries. This one's not that bad. Not that bad. And
lots of inspirations for people wanting to build their own. Yes, it's definitely a really good one to get started with.
Oh my god, it's so much lighter. It's like basically double the
the weight
or
half the weight of the lightsaber builds.
Right. The polycarbonate is thick and weighs a little bit more. So that's fun. Yes.
So, continuation of some more props that will be coming up next. We said before.
More lightsabers.
Yes.
I need to make a stand for this. I never made a stand for this. I need to make a stand. I made some wall mounts, but like I don't want to drill into the wall right now. All right, man, we gotta go.
That's it for the lightsaber.
Yeah. We're gonna run through the time lapse.
Oh, okay, yeah.
So here is.
But yeah, that's this week's time lapse. Super cool use of multi-material, not printed, but used in the actual print. This is a really cool clear dice tower. And what impressed me was, first of all, the staircase printing. Tip on printing the staircase: if you're trying to time lapse it, it'll probably fall over, even with the Z-hop on it. So I had to turn off the time lapse for that, but we were able to get a very nice fail. And what I'm using for the clear part is the transparent sheets that are used for like
overheads, binders, that sort of stuff. So it's an 8x11 sheet. You wrap it around, and you got some tape here that's transparent.
See where it's connected together.
But this is such a great little way to create this kind of custom, kind of glass-looking thing, and it works pretty well for
be able to see everything going down. It's really cool, especially when you're playing a game with these. Of course, the dice. These dice are all 3D printed as well. You can just search for dice. You can see one that has like all these D10s and 20s and whatever, the numbers of them. And these are so fun.
There's a bit of a lip here, so you can see that's where press fits into, so that the print is what keeps its shape. It helps keep the sheet's shape. So it just press fits into that. Same thing with this right here at the top, right? There's like a bit of a cup.
There's two little pieces right here that hold the transparent sheet in place.
It's so detailed. I love this thing. Like all these little bits there. It's so good.
Yeah, there was a bunch of retraction goop that you just clean up with an X-Acto knife, and that cleans up very, very well.
Cool. And here's a little edit of kind of the behind the scenes of putting it together, getting shots of it, and actually creating the bit. Here's the fail. Get a little bit of a rat's nest, or maybe it's a bird's nest.
Even with a brim on there, it's still going to fall over, at least for the time that I had. And again, there's a couple of times where I don't do a time lapse just because it just would not print with the Octoprint's time lapse mode. But here you can see how it's printing this 45-degree angle on that, and successfully printed after disabling the time lapse.
That's great. Challenging print, but there we go.
Totally worth it though.
So folks, if you want to...
Oh, and if you skip a little bit more, you can see the actual brand of the transparency sheet that I use. It's the one that you can find on Amazon.
Yeah, we also
Transparency.
link to it in whatever Learn Guide we used it before.
Somebody mentioned that the guy here.
We're not on time, Pedro.
Oh,
Like-
you're using like soda bottles or something. So there's other clear plastics that you could use.
Okay, and then huge shout out to Hippie Ninja.
Wow, these look good.
Hippie Ninja shared this with us on Thingiverse. I really appreciate this. He made this as an Xmas present for his wife. She loved it, and is going to add a nose piece of TPU to give it some cushion. That is so great to see.
Wow.
Excellent.
All
Really,
the
really
colors.
fun. Yeah, really fun silk color there. All right, and the last one that we got this week was the Octoprint Raspberry Pi Rig, the 3.5-inch Pi TFT touch display. Super cool. I like the description as well. One of his first makes. Put together a Pi hole and wanted a case for it.
Very cool.
This fit perfect. Like that. Yes.
I think we're gonna have to revisit the Octoprint Raspberry Pi.
You think?
A little rig. Yeah, the one that we have here is, you know, it's a little old.
Okay.
We'll definitely have to update it to make sure that it fits the Pi 4s.
Okay, and I forgot to say, yes, Pedro, he put a link there, but I do have 2 level tutorials on the Darksaber, particularly a CAD walkthrough and then a step-by-step on how I split up the parts for smaller printers.
The small parts are already there if you just want to print those off.
All right, well, tonight we hope to see you on Show and Tell. It's at 7:30 p.m. Eastern Time, and then Ask an Engineer work happens right after that. Sorry about the end of the show, but we did walk through the things in the beginning, so I'm not going to do the thing. But thank you so much for joining us, and we'll see you later tonight. But until then, remember to make a great day. And may the force be with you. Bye,
See you later
folks.
tonight, folks.
We'll see ya. Bye.